Welcome to my AirDrop Forensics talk. I really appreciate that you chose to spend this afternoon with me, or a bit of it. And before we get into the nitty-gritty of AirDrop, I just wanted to introduce myself briefly. So my name is Kinga Kieczkowska. I am Polish, but I live in Scotland. So, I came here from sunny Edinburgh. If you've ever been to Scotland, you know that's a joke. So I work as a cybersecurity consultant at Rada Cyber Security. That's my own one-woman consulting company, but I also do security architecture at an unnamed bank in Scotland. And kind of after hours, I am a macOS forensics, macOS and iOS forensics geek. It all started with my university dissertation that I wrote probably like 5 or 6 years ago now, and that was on macOS thumbnail caches. So I started kind of poking into the complexities of macOS and different forensic artifacts, and that's kind of where it all started. It's a very niche interest. Let's say it this way, like there isn't a lot of people who are looking into it. I feel like there's a lot of resources and articles and blog posts on Windows and Linux, but there isn't that much about macOS forensics. So I kind of saw some potential there, that there is a gap that I could fill, and that's where it started. I'm also a community organizer myself. I started and I organize Women in Cybersecurity Scotland meetup, which is greatly inspired by Wicca. So we are nowhere near as big or well organized, but we do meet, let's say, around quarterly in Glasgow or Edinburgh. So I thought that would be a good fact to drop at this conference. Exactly. So let's start with the actual topic, AirDrop. Before we move to AirDrop, can I see a show of hands who uses iPhones or macOS devices of any sort? Okay, a lot of people, that's good. Some rooms are quite tough with this, because sometimes I get no hands whatsoever, or like a couple of embarrassed hands. But yeah, I like Apple, so I understand that. So if you use the devices from the Apple family, you will probably be familiar with AirDrop. So AirDrop is the Apple's technology of transferring files between devices from the Apple family. So it works on mostly, I think, when people think about AirDrop, they're thinking about iPhones. So you can send files between iPhones, but it also works between iPhones and MacBooks and iPads, also iPods. I'm not sure if you still remember that those exist, but they do. So you can use that as well. And all this sort of devices within the family. So the technology is based on Wi-Fi and Bluetooth. So it's a kind of a little bit of both. Basically, Bluetooth low energy protocol is used to discover the devices to send to, and then there's another kind of proprietary protocol called Apple Wireless Direct Link that creates that connection like Wi-Fi to send the actual file, and the transfer itself is also encrypted. So I'm mentioning this because we're going to look at some logs, and knowing kind of this background about AirDrop helps us kind of know what to look in the logs as well. And here on the slide you can see just what kind of the short version that Apple gives on their website to explain what it is. So I'm just wanted to give some context, let's say, to the scenario that we're going to look at today. So I am sending some files between an iPhone 15 that's running iOS 18.01, and I'm sending and receiving these files with a MacBook running macOS Ventura that's 13.6.6, and that is important because these things change, like the level of logging and what you can find in the logs really changes from different operating system versions. Unfortunately for me, there's less and less things that get logged, which in general is probably a good thing from a privacy standpoint. However, I know that people who develop things, software and applications for macOS and iOS don't always like it because it also makes debugging harder. However, it's important to note that, because if you're using a different iOS or macOS version, your results may differ. So that is just a disclaimer. And also another thing is that I'm going to say that I am focusing on the logs that are present on the laptop only, and the reason for that is that it's actually really difficult to get into your iPhone's logs. The full kind of physical acquisition of an iPhone is only really possible if you either jailbreak it or if you have kind of specialist software or even hardware to do that, which I don't have because this is not my day job. So unfortunately, I don't have access to software like that. Whereas on your laptop, it's obviously much, I don't know if it's obvious, but it's much easier to access those logs and analyze them. So what forensic artifacts we'll be looking at today? We'll cover 3 different things. One is unified logs, second is extended attributes and file metadata, and then we'll also look at the quarantine database. I'm going to explain each one, so this is just a let's say a quick look before we continue, but don't worry if you don't know what those are. We're going to start with unified logs. So what do I mean when I talk about unified logs? Apple Unified Logging, also referred to as AUL, if you maybe see it somewhere, was introduced in around 2016, and it basically replaced all the text-based log files you might be familiar with if you've ever looked at Linux systems, for example, like varlog, system.log, and stuff. The unified logging provides this sort of I want to say unified view and like almost an interface that allows you to query the logs, and like all the logs are accessible to you in one place in your terminal, and you can interact with them kind of much more seamlessly than if you would have to go and look in all sorts of different files. However, obviously it's a bit it might be a bit confusing if you are used to doing forensics work on a different system. But once you get used to it and you learn how to query them, I think that it's a great interface for forensic work. So here's just a very short video showing like what it looks like. So here what I typed in on there was just log show and the last 15 minutes. So basically my terminal is showing me the last 15 minutes of logs, and there's like everything in there, right? So like you can do like, usually when I do experiments with AirDrop or otherwise, I'll do like 1 minute, and it will be like thousands, like 11,000 lines or something. So obviously everything that's happening on your machine gets logged there. So it is important to learn really what you're looking for and know how to query those logs, because otherwise just the vast volume of data that you're presented with, like it's not like really productive to just like kind of go and look through it, because there's too much of it. Like you'll spend 15 minutes and you're still like in the same second of the logs. So when it comes to actually interacting with the logs and getting what we want to find in there, there are different queries that you can construct to get the information that you need. So here's an example. this is obviously not like a whole row of the logs, but basically there's some color coding to the logs, automatic color coding already, so that helps you really differentiate between the different parts in like one log entry. So first you'll have like the process image path, it's called. So it will be like the agent or the like service that kind of produced this row of in the logs. Then you will have a subsystem, for example, Apple sharing. That's just kind of the application bundle naming scheme that Apple has. And sharing, Apple sharing is one that has to do, as you can probably guess, with sharing. So AirDrop is included, but also downloading things, for example, from browsers and the general internet are also covered by that. And then you will have that subsystem, a category, for example, AirDrop, and then there's an event message. The event message is kind of the free text, let's say, part of the log entry, and you can filter by that as well. So that's good because you can like look for specific strings in that. So under the kind of predicate diagram, let's say diagram, you can see some just examples of I don't know if I have the laser. No, I don't know where it goes. Oh, the laser goes here. Okay. Here, you can see some examples of queries that I've written. So you can do log show and then predicate, and then in that predicate, you are, kind of putting your query. So you can, basically the language is really easy. You just, specify what you want it to contain. I always do contains. I think you can do equals if you're like really sure what you're looking for, but contains it's safer because obviously it will show you things that contain more than just what you're looking for. And you can also specify like what's the amount of time that you want to look in, because as you can imagine, if you just run a command without that, for example, last 2 hours or last 15 minutes, it can take ages to process all the logs that you have. So it's good to have an idea of what kind of time period you're looking at. Another thing you can do is instead of log show, you can do log collect and then save the logs that you want into a log archive, and then work like on the log archive. All you have to do is specify then like an output, like an input file while you write the predicate. So then you tell it just to look in that file and not in the logs that are actually present on the laptop. So the way I would do it, I would first do log collect all the logs, for example, for 15 minutes, and then run my queries on those logs. Because I think that it is a bit dangerous to kind of run your predicate query on your logs and then save them, because sometimes you forget that you've already filtered, and then you end up looking in a kind of already limited, amount of logs. So I would, if you want to do it, I would advise to decide on a time period you want to look in and save that and then work on that. So first thing that I wanted us to look at is the forensic artifacts of file ingress. So when you send a file from an iPhone, for example, in my case, that was what I was experimenting with, to the laptop. So the first thing you're gonna want to look at, I hope that the yellow highlight is visible, is an entry that starts with transfer and like this long transfer ID. You can see here there's the services sharing D, and that's exactly the example we had before, Apple sharing and category AirDrop. And we already in that first entry will have some important information. So first of all, you can see the sender name. So this will be the name of the device that sent you a file. You will also get the file type. Unfortunately, it's not the file name, but it will be the file type and also how many files are here. And you can see there's a couple here, because here in another transfer here I was, for example, sending a video on top of here, you can see a photo because this is like Apple's photo format, the HEIC. I never know how to pronounce it differently. So yeah, this is like the basics, which is what you want to look at. However, it is easy to like see that and think, okay, I can see there's a transfer, so just kind of assume a transfer has happened. But actually, no, because another thing that you need to look at is the two options, whether the transfer was accepted or rejected. Because, you know, when you send something over AirDrop, the person who's receiving it gets an option, like you can be like accept or decline. It doesn't, I think maybe if you are logged into the same iCloud account, it's possible that you don't have to accept every time. But in general, if it's two different devices, it will ask you. So actually what I found is that in both cases, you can't see here because it's overlapping, but both accepted and rejected transfer have this like initial message. So it's important not to kind of get swayed by this. But then you have to look at kind of the whole sequence of the logs and look for the user response. So here you can see user response accepted for transfer, and here you see user response cancelled for transfer. So this one on the right was a transfer that was attempted, but it was not completed, versus this one that was accepted and completed. So at first it might feel a bit counterintuitive, but when you really think about the logs that we're looking at here, which literally like log every step of the way, so that makes sense that it's not just that you'll have like one message that says, yes, this transfer has taken place and this is what was in it. Like every, you know, I don't even know if it's like microseconds or whatever, but like, you know, there's a lot of logs for the whole process, and it's not just kind of abstracted to a transfer. So make sure that you always check that, because it's easy to maybe be a bit confused and get prematurely happy that you found evidence for something only to see that it hasn't actually been completed. So here I'm looking at an egress transfer. So I am sending, using AirDrop, sending files from my laptop to my iPhone. So that looks completely different. And here I have cut this, I don't know if I can go back. So I appreciate the view is a bit different, but I basically cut all this like first bit of it, each log entry, just because it was impossible to show it productively on a slide. But I'm basically showing you only what comes after the sharing the bit. So in this case, when we look at files being sent from the laptop, we are looking for an entry that starts with start session client 4. And here again, over here, we can see the device name, and also there's a device ID here. This device ID changes with every AirDrop transfer. So even if you send another file like 5 minutes later to the same device, this ID will be different. So it's kind of only means something within the context of one transfer. I'm just saying this as, you know, you can maybe think that it's connected to the, like, one hardware device, but it really isn't. It's just, connected to this one transfer. So here we are looking for start session first, and then, sending upload request, and then AirDrop sending. This uses this first, ID that was mentioned here. And likewise, like we did before, we want to see what the difference is between when the transfer is accepted versus rejected. So in this case, you can see that in a rejected case, we have the start AirDrop session here, and we have a message that says sending upload request, and this is a different example. So this, this ID is it's not going to be the same because it was a different transfer, is what I'm trying to say, but it will be the same as here always. So there is a sending upload request, but then there's power assertion released and AirDrop client transaction ended. So it looks like a request was sent, but there was kind of no answer to that. and compared that to a successful transfer where we actually get a log entry that says AirDrop sending to, and then the device ID. So this is the one that we're looking for when we're looking for a successful transfer. And then in the end, these kind of end of transfer logs still get logged, but there's more that actually shows the sending. So this is what I've been looking at, but as I said, there's a lot of different logs to look at, and I am not a very kind of low-level person. Like, I don't really know, for example, the ins and outs of, the Bluetooth protocol or things like that. But if you do, or, if that's kind of your cup of tea and you're interested in it, then there's a lot of logs, like with Bluetooth, about Bluetooth themselves. So like the agent, like kernel, Bluetooth, the airport, the running board, a lot of these different agents will create a lot of logs. And I'm 100% sure that there is more artifacts to be found there, but I kind of focused on these, let's say, more AirDrop specific. But I think especially in the Bluetooth one, if this is your cup of tea, that would be the place to look and decode what you can get from there. I have experimented a little bit with like the RSSI value in the Bluetooth logs, because that's, at least theoretically, it's supposed to tell you how close the device is when it connects to your other device. So I thought that was interesting, and I've done some experiments, but I didn't really get very reliable, let's say, or consistent results. And then I started reading about all the waves and how they like get reflected on things, and I was like, okay, this is not actually what I was trying to find out with this research. So yeah, there's plenty to get involved in that if that's your cup of tea, is all I'm trying to say. So the next type of forensic artifact that we'll look at is a pretty simple one. So that's file metadata. So you can either get it by looking at the kind of the get info option when you right-click on a file, kind of in your normal UI in macOS, and that is what you would get here. And then you can also use the command line utility MDLS, so just list metadata, and I'll show you what you get from there. So, excuse me. A lot of the data you'll get here is again the sender's phone name, and then you'll get some other details, technical details about the device. You'll also get latitude and longitude of where the photo was taken. In this case, we're talking about photos, could be something else. It's not maybe that immediately that interesting, but obviously it depends on like what is the reason you're doing all of that investigations, because as it is in forensics, every little fact could tie it to some other piece of information you have from another source. So even if it doesn't, I'm not sure, the coral profile or focal length doesn't seem very important on its own. Like you never really know what your situation is going to be like. So it's good to know where to find it. So this is just more of how it looks like when you use the command line utility. Maybe if you are scripting some of your investigation, if you're running some sort of reports, like I do a bit of automation of this with Python, then you might want to use this as opposed to the UI. Obviously, and I just highlighted a couple of things again, the device model, the file type, the creation date, and there's also latitude and longitude as well. So I wanted to mention extended attributes here as well. So extended attributes are key value pairs that hold some additional data about a file. So some examples are, for example, Apple quarantine, and I'm going to talk about quarantine in a second. Or there's an extended attribute called item where froms, which holds the name of the sending device. And coming back to the quarantine extended attribute holds information for the macOS system among other things, to know whether or not to quarantine a file. So you can see here in the screenshot, I downloaded the application of Spotify, and this window pops up asking me if I want to open it. And it pops up because the file, when it gets downloaded, it will have an extended attribute appended to it that has a flag for the system to ask, because, for example, it's the first time that I'm opening it, or it's not recognized by the system as secure. So this is what it looks like, and you can read the extended attributes. I'm sorry, this is a very ugly slide, but I tried to take a screenshot and it looked even worse. So we're stuck with this. You can use this xarcher module. That's a Python tool, and then you print the value of a specific extended attribute. If you want to see all of them, you can do xarcher -L, and then it lists all of the ones that are present. But I am interested in the quarantine one, because I know, and obviously you give it the file name as well, and it gives you this collection of 4 strings, let's say, and let's look into what they mean. So this is the same string, just put here. The first one is these are the gatekeeper flags. Gatekeeper is the kind of technology behind the quarantine checks for the files that you download or receive. And in this case, I never checked what the flags would be for the quarantine window to pop up, but the 0081 are kind of the safe flags, because that's what is on all the files that you can just open normally. Then the next bit here is the timestamp of when the file was downloaded or received, and the timestamp is in hex. You can use an online converter, or obviously do it programmatically if you want. You can see that I have updated my slides 2 days ago at 10:30 p.m. so that is correct. And then the next thing here is the agent, so sharing D for downloading and sharing via AirDrop. I'm actually now thinking what other thing, maybe if you copy it from a USB stick or some external storage, that would show something else and still apply the quarantine flags. And then the last thing is just a unique file ID, which I have not found it anywhere else, but whenever you dig in logs and find some sort of an ID for something, it's always good to make a note out of it, because you don't know where you can find it in another place. So it's good to know that there is this unique file ID there, although I have not found in my research yet what it can be kind of correlated with other than these artifacts. So the last thing that I want us to look at is the quarantine database. So we talked about extended attributes. So if you have a file, you can view of that file the extended attributes and see that data. But there's also a database where you can see all of these things in one place. So the database can be found in your home directory, library, preferences, Apple Launch Services. And this last bit is just the name of the file. So if you wanted to navigate there, just go to the preferences and then open this file using, for example, SQLite, I think DB browser for SQLite for Macs. This is kind of the basic software that everyone uses for this. It doesn't have like the SQLite ending, so it's not going to kind of open itself in the app. So you just have to know that is the database, and it's like one table called ls quarantine event, and it has some fields of interests that we might want to look at. So there is the quarantine event identifier, so the same value as we got in the extended attribute. Then there's a timestamp again. There's an ls quarantine sender name, so obviously also the same as we saw in one of the extended attributes, the where froms. There's also the agent name. It's always sharing D for AirDrop. And here, just with a kind of smaller font, I also included some fields of interest for when you're looking at browser downloads. So you can actually see, I think, possibly in the next slide I can show you, but you can actually see the top level domain or where it was downloaded from, and an actual link to a file as well, and the browser name too. So that's really helpful. Oh yeah, you can see it here that there's a lot of Chrome, and here the sharing D, that would be AirDrop, among other things. And you can see how there's a number of links here, and the event identifier and the timestamp. So before I go to the next part, which is talking about some real-life AirDrop exploitation, I just wanted to address the fact that maybe you're wondering that I've kind of given you a couple of different places where you can find forensic artifacts, but they are all the same or very similar, right? So like I gave you probably like 2 or 3 ways or places to see the sender name, or places to see, the file ID, or the creation time, and all of that. And why is it important that we all know, that we know all the different places? Well, when you do like a real forensic investigation, it's different than, just sending a photo from your iPhone to your laptop and then immediately checking the logs, right? Like it might be a lot of time might have passed, and these I haven't done experimentation on the quarantine database to check that, but when I did my dissertation in thumbnail caches, I found that there's a database, and it caches some thumbnails, so you get some good data. But once the database reaches 0.5 gigabyte in size, it just deletes itself and then starts from scratch. So it wasn't even like, first in, first out kind of situation. It was just like it would purge itself and then start again. So like you never really know how much, which of these artifacts will be available to you. And another thing is that once you move a copy, for example, a photo from one place to another, like on your disk, these extended attributes sometimes get lost. If you upload things, to let's say a photo to a let's say WhatsApp or Facebook, and send it like this, not all of this will persist. So it's important to know that there's, multiple sources you can get this information from, because you won't always have everything ready in front of you, as you do, obviously, if you're just trying things out at home, experimenting. So just want to give a disclaimer. And now I would like to, at the end, just talk a bit about how is it kind of exploited in the wild? How is AirDrop used? And first, I have this funny video taken from, I think, TikTok. So you can see here, a guy is on a plane. He's airdropping everyone on the plane, saying, "This is me flying this plane." And there's no sound. I'm sorry, but basically the pilot has to address the whole plane, saying, "This wasn't me. I'm not just sitting here sending you, shirtless photos saying I'm the pilot." So basically, this was like a funny intermission, let's say. But basically, the issue, and you could say that it's also a value of AirDrop, but the issue is like how private it is, and how it's really hard to really map, kind of productively map a device to the file that was sent. Like it's not, if you just get a file through email or Messenger or something, like you always can tell where it came from. But it's not like this with AirDrop, and I don't fully understand why, because it's a kind of close proximity system, right? So it's not like you are going to, who that person is anyway. So, I don't know why they did it that way. But here's just, 2 examples. One is, from, I think somewhere in America there was, some, situation in a school. I think a lot of the kind of bad situations that I hear about consider schools, because when you think about a lot of kids with iPhones in a small proximity of each other, like if everyone has their AirDrop open to everyone, you can just like click on all your friends and send one thing, and no one will be able to tell that it's you. So unfortunately, it turns into some swatting situations and like threatening, your whole class or things like that. And here there's also an example where someone contacted me on Twitter asking for literally the same thing, help with students sending threats through AirDrop. No one is able to tell where it came from, and it's not, it's really hard to kind of combat. So obviously, privacy in general is a good thing, but especially with this, there has been small steps that they have, and by they I mean Apple, that have been done to improve this situation. So, for example, you might remember that in the past you could just set AirDrop to be like open or open to your contacts or like off, and now the only way you can open it is like for 15 minutes, and then it will lock itself down on its own. You can't just turn it on and always be open to connections from whoever. So they are trying to address it, but I'm not sure if it really addresses what a lot of people are still struggling with, which is like lack of accessible logs. And obviously, if you send to a laptop, you are able to see a bit more data, but with the phones, first of all, it's harder to get the logs, and a teacher is not going to jailbreak an iPhone to look into the kind of hardware logs and check who sent what. So thank you very much. That was my talk. Here is a QR code that takes you to my LinkedIn. I didn't put these slides anywhere, but if you'd like the PDF of the slides, then please add me, message me on there, and I'm happy to share or chat more if you have any insights. And also, if you have any questions, please fire along. Thank you.
Thank you so much. Okay, any questions? Yes.
Hi, thanks for your presentation. Do you know how long is the data retention of the unified loss of the AirDrop information?
That's a good question. I'm not sure actually, but I think that based on the work that I've done previously, I think it will depend also on your storage, possibly, but I haven't checked that. So I'm not sure.
So you made the AirDrop and then directly the experiment, so it was just a few minutes ago?
Yeah, but I think I'm not 100% sure about all the logs, but what I found that sometimes it's quite unpredictable what gets saved and what doesn't. Like I would find some things that were like 2 years old, but not something that was, happened like half a year ago. So I think that it's not, it depends on the system, I think. So, or in this case, like the agent that's logging. I don't think it's that straightforward that you can be like, oh yeah, just a year or a month or an hour. But definitely I think it's, I don't want to say a number because I don't know, but it's not a couple of minutes. It's longer than that.
Interesting. Thank you.
Yes.
Great presentation. So you covered a lot of how to use the logs for investigating and looking at details. Have you looked very deeply into how well protected the logs are in terms of integrity mechanisms, or like the fun, and I'll give you the hint, your laptop and Apple Silicon actually measure time differently, like in the mock versus ticks, and like that leads to its own fun for correlating logs because you have to actually have the hardware ID to convert to nanoseconds, or it gets messy.
So I looked a little bit at kind of the protection mechanisms, and I mean the protection mechanisms are the number one reason I'm not looking into the iOS side of things, because it's hard to get into it. When it comes to unified logging, I'm kind of focusing on the logs themselves. I'm not kind of really looking at it too much from like an adversarial perspective or like anti-forensics or like how I would be able to, break the protections. It's my own laptop. I'm logged into it, right? So I'm kind of not too much on that, offensive side, let's say. But there's this, like whole kind of, let's say, body of work that people are looking at. The Apple has the TCC, mechanism of making sure that, specific logs of specific things are protected. So I have looked at it in the past because I looked at the notification center, database in Macs that turned out that they logged like, for example, if you got like a little notification of getting an email through the mail app, actually it logged the whole email, even though you only saw like 20 words. And then it was like in an unprotected database that any application could access. So there are definitely issues with this, but I'm not really focusing on that, too much. However, if you are interested in it, then, I can give you some resources of like other people in the macOS community who really love breaking the TCC, basically. So,
thank you.
Oh, yeah, no problem.
Maybe a last question. Yes, perfect. Thank you so much.
Thank you, Kinga. Very insightful talk. My question is, can we disable the logging on AirDrop without affecting the functionality on macOS?
What do you mean? Sorry.
Can we disable the logging?
Oh, disable the logging.
Yeah.
That's interesting. I haven't thought of that, but I think that from a user perspective, like if you weren't. If you are just a user of AirDrop, like you already kind of don't have any logs that are like available to you, because there isn't, as I said before, there isn't like a transaction history for AirDrop, right? The same way that maybe there is when you send an email, obviously. So there isn't like a UI, view of this. So there isn't a setting not to log it. I'm not sure if there's like a kind of more low-level way to turn it off, but I would imagine not really. But I'm not sure. Maybe there is a hacky way to do it.
Okay, thank you.
No problem.
Well, thank you so much for your talk.
Thank you.
Let's give her applause again.
Thanks, everyone.